Hello, boys and girls. This is Mr. So. Welcome back for another lesson of biology. Today we are going through lesson 18 about pedigree in the genetics. Before you start watching the video, remember to like and subscribe my channel and also share the video to your classmates. Let's start. In order to study genetics or human inheritance, sometimes we study the pedigree, or we call it the family tree. Take a look at the family below. You have parent number 1 as the father, which has a square representing, and then parent number 2 as a circle, which is the mother, and parent 1 and 2 together give birth to offspring 3, 4, and 5. By studying the pedigree, we can also find out the allele of a character, whether it is dominant or recessive. Let's take a look at the example of the inheritance of six-toed foot is controlled by a pair of alleles. In order to find out whether the allele for the character is dominant or recessive, we must take a look at a specific pattern of pedigree or family tree. That is, for the pedigree, it must have the parents, both the father and the mother, having the same character. And then they give birth to different character offsprings. How can we make good use of this family tree pattern or pedigree pattern to determine whether the allele of this character six-toed foot is dominant or recessive? In order to do the question, we have to first take a look at the parents. For parent 1 and parent 2, both of them, they are six-toed. And therefore, each of them, they must have the six-toed allele to show the six-toed character. But we don't know whether parent 1 and parent 2, each of them, they have one six-toed allele or two six-toed allele. So we will say that for parent 1 and 2, they are six-toed, and each of them, they might have at least 至少 one allele for six-toed. So let's write it down. For parent 1 and 2, they have at least one allele for six-toed. Allele for six-toed. Well, for parent 2, same case. Allele for six-toed. After looking at the parents, we have to look at the offsprings, who are different in the phenotype from their parents, such as individual 4 in here. Individual 4, he is different from his parent. He has normal feet. So individual 4, it must have at least one allele for normal feet. Let's write down allele for normal feet. And since 4 is the offspring of parent 1 and 2, individual 4 must get this allele of normal feet from their parent. So it must come from either parent 1 or come from parent 2. Therefore, we will say individual 4 has normal feet. He has at least one allele for normal feet, and it comes from either parent 1 or parent 2. If this normal feet allele come from either parent 1 or parent 2, then parent 1 or parent 2, they might also have the allele for normal feet. Same case for parent 2, allele for normal feet. So for parent 1 and parent 2, they might have two different alleles in their chromosome. One allele for six-toed and another allele different, which is an allele for normal feet. So we will say at least one of the parents they have different alleles in their chromosome. So at least one of the parent is heterozygotes. They have different alleles in their chromosome. And you have to know, in a heterozygous condition with different alleles in their chromosome, only the dominant allele express. While for the recessive allele, it is always masked, not shown. And for parent 1 and 2, they are showing the character of six-toed. Therefore, for the character showing, the allele for six-toed must be the dominant allele with a stronger power to express. Next question, can you state the possible genotypes for individual 1 to 5? In order to do that, you have to first let the allele. We let the allele for six-toed foot be capital letter F, because from the last slide, you know the allele for six-toed foot is dominant. While the allele for normal feet, you let it as a small letter f because it's recessive from the previous slide. You do it already. And then let's take a look at the individual 3 and individual 4 first. They are both normal feet. And if they are normal feet, they must have two recessive alleles for normal feet. Therefore, their genotype will be small letter f, small letter f. For 4 as well, small letter f, small letter f. And then let's take a look at the parent 1 and parent 2. Parent 1 and 2, they are showing the dominant character, the six-toed foot. So they must have at least one allele for the six-toed foot. Alright, so let's write it down. For 1, it must have at least one capital letter F. So as 2, they must have at least one capital letter F. But for individual 3, they are having a child having two alleles of small letter f, recessive normal feet, and these allele, it must comes from both individual 1 and individual 2. Therefore, for individual 1, not only does individual 1 has a allele for six-toed foot, big letter F, it must also have a small letter f allele for the normal feet. So as the case for individual 2, it must also have a small letter f allele for the normal feet. Last but not least, what about individual 5? What might be the possible genotype of individual 5? It can be either capital letter F, capital letter F, being a homozygous dominant, or it can be a heterozygotes. The idea is very simple. You can draw out a genetic diagram to get the genotype of individual 5. It can be either one. You don't know which genotype it will be. You don't know whether 5 is a homozygous dominant or heterozygous. So it can be either one. So you are not sure about the genotype of individual 5. Since we know that for both individual 1 and 2, they are both heterozygotes, so let's write down the genotype first. They are heterozygotes. One big letter F and small letter f, while for 2, same. One big letter F, small letter f allele. And now, given the idea that both of them they are heterozygous, can you get the chance or the percentage of having a six-toed child for individual 1 and 2 in the next pregnancy? So if individual 1 cross with individual 2, heterozygous crossing with each other, you will get the six-toed foot to a normal feet 3 to 1 after drawing the genetic diagram. Please go to your textbook page 31 to do a MCQ there. That's it about a part of how you can use a pedigree to determine whether the allele is dominant or recessive. In the next video, we are going to take a look at classwork 26.3 and do some questions about the pedigree to strengthen your understanding. Stay tuned. See you in the next video. Bye bye.